So, biomass, biogas, biofuels, and its energy storage. So I'm going to try to address very quickly the processes. So dry biomass, energy storage, wet biomass, ethanol production, biodiesel, Nova Bio, and carbon capture storage, biomass carbon capture storage. There are a lot of topics. I'm going to talk about them in 2 hours. So I'm not going to go too much in detail in each one. I'm just going to talk mostly about the process, how it works, the markets in Brazil, and the alternatives for energy storage for each of them. Please let me know if you have any questions on the way. So starting with dry biomass, we have 3 main inputs for this type of processes, which is agro waste, urban solid waste, which is plastics, paper, cardboards. So is organic waste, which have less than 20% of humidity of water inside the urban solid waste, and also energy crops like eucalyptus, pinus, and other energy crops which are not trees, but they have like plants and different ones. So within this the primary source of biomass energy, we have options, different options for energy storage, which one is energy crop storage. This energy crop storage, I came up with this concept and I published a paper and has been cited so far. I'm going to explain how it works. You have pellet storage, which the idea is to create pellets from agro waste or energy crops or urban solid waste and store these pellets, these huge domes. And the other option, so from these biomass, dry biomass, you have 2 main options for generating energy, which is to incinerate biomass in large incineration plants or thermoelectric power plants. They usually have to have a capacity higher than 30 megawatts in order to be viable, because these the boilers, they need to be big in order to increase the viability and compete with other sources of electricity, for example, wind, solar, gas, coal. So they have to have this big capacity. The bigger the biomass power plant, the cheaper it is. And the other option is gasification. Gasification has the advantage because that it does not require a very large reactor. So the reactor can be small, mainly because of the very high temperatures. The efficiency of turning the biomass into syngas is high, so it doesn't need so much volume. So the volume area ratio is not so important because of the very high temperatures, which increase the efficiency of the process. And so you can make one of these plants viable with less than 1 megawatt, so 200 kilowatts of capacity. It's already can be viable alternative. Of course, if the material that you use is not so expensive or even free, or even you get money to get rid of the project, these wastes. So agro waste, you have to the person that's planting and producing this waste have to get rid of it, and this is another source of income for this type of solution. So incinerator can generate electricity and heat, similarly to a coal power plant. Gasification is different because it produces syngas, which is hydrogen and carbon monoxide, and then you can generate electricity, heat. You can separate the carbon monoxide and have hydrogen. You can have produce with this syngas liquid fuels like diesel, ethanol. You can produce fertilizers and other chemicals. The other advantage of producing syngas is that you actually can store the same gas for daily and weekly storage, which you cannot do with biomass plant. A biomass plant is usually a base load solution, so it generates electricity throughout the whole day, throughout a whole month. But this gasification type of solution, you transform the biomass into the syngas, and then the syngas you can store similarly to biogas or natural gas, and then you can use it for peak generating during moments in the day when the electricity is more expensive. So from the biomass, looking into the resources, when you're extracting wood and producing wood, for example, for eucalyptus plantation, you have the option to use this resource for wood production, for construction, civil construction. You can use the wood for cellulose, for paper industry. You can use the wood for a biorefinery, which has been developing in Europe mainly. And you also can use the wood from these forest plantations to use for biofuels. Mainly the wood, which is a low-graded wood, which is small, which is irregular, which doesn't have the qualities for sawmills or for paper production or biorefinery. It's used for fuel. This mainly happens in the US. In Brazil, it changes because of the location, the distance from a paper industry. So maybe it's too far from the industry, so all the wood goes for incineration. But this would be the ideal way to manage energy crop. For the same energy crop, you have several products from the wood. This is an example for how the European Union uses the wood. They use wood for paper industry, for refinery, construction, civil construction, and energy. Part of this is with the production of pellets production. In the US, they have around 40% for paper production, another 40% for construction industry, and then 15 to 10% it's used for fuel and other industries. The US is the country with the highest wood production, after India, China, and then Brazil, Russia, Canada, according to the FAO. FAO is a food regulator. It's an agency from the UN that regulates food products. In Brazil, we had the production of wood increasing significantly around from 2000 to 2008, for example, mainly due to the increase in exploitation and civil construction. But then you have a large decline, and it's a very volatile industry. So having as many products that you can have from this dry biomass, the better, which one of them is electricity generation. So this is the exportation of wood from Brazil, Pinus. The main states for production of this the wood and exportation is Santa Catarina, Paraná, then Rio Grande do Sul, which is the main markets, the main states that produce and export wood. And the countries are the US, Mexico, China. And looking at the whole arable land in Brazil, we have the eucalyptus takes around 2% of the land, pasture 15% 58% crops thing, and 24% of the arable land is not used so far in Brazil. And so there is a lot of land available for example, biomass electricity generation, to produce biomass for electricity generation, not all the other markets that we had talked about. And this energy crop storage solution, which I propose, is very focused on the Brazilian case, which varies with the amount of hydropower generation that is available in Brazil. For example, in a year that you have very wet year, that you have a lot of hydropower generation and the cost of electricity reduces, you don't need so much of thermoelectric generation from natural gas, from biomass, from coal. One solution, one alternative would be not to use the biomass that you have available for electricity generation. You would allow it to grow instead of cutting and using it. And then when you have one dry year or two or three, several dry years, you would increase the amount of biomass consumed, so the average age of your biomass plantation will reduce. So in a dry year, you have, for example, a 90% capacity factor for your biomass plant. In a wet year, you only use 50%, mainly in the dry season or when the price of electricity is lower, and you allow your biomass energy crop to grow inside. So this energy crop management alternative is appropriate for Brazil because of this variation in costs throughout the year. For example, you have 30% of wet years, 30% of dry years, 40% of average years. So when you have wet years, you just allow the overall size of your plantations to grow. During dry years, you reduce the age of your energy crops. The growth of eucalyptus trees, they increase significantly in the first 3 years. The amount of mass that it grows, so the speed in which the eucalyptus grows. Usually, eucalyptus trees, they're cut after 4 or 5 years in order to increase the efficiency of the plant, of the equipment, of the people working in these plantations. But so the growth of the wood reduces, so the amount of growth per year reduces, but you still have growth in these plantations. So for example, if in this particular year it's not worth for you to cut and use the biomass, if you were not going to make so much money with the wood, you might as well leave it to grow more. So you increase the biomass, and then you can later use it for electricity generation, particularly when the price of electricity is higher, in order to produce electricity. And yeah, so in this paper, I try to create scenarios, different scenarios, and I show that yes, the payback period doesn't vary so much if you cut the trees in 4 years or 8 years. So the payback is similar. So it makes a lot of sense to burn the wood when you make more money, when you have a higher return ratio. And another particular issue for biomass plantations is that the biomass, the eucalyptus, the pinus, it has to be planted around 50 kilometers radius for you to make incineration, a power plant viable. For example, with more than 20 around 20 to 40 megawatts. You need that the area surrounding the plant, at least 2 to 5%, is biomass plantations in order to make it viable. So below this, you would think about using gasification as a solution. I'm going to talk about gasification in the next slide, not further on. So another option, which is very used, particularly in the US, in China, in India, in Europe, is the production of wood pellets, and it's also easier for storage. The production of wood pellets, particularly in Brazil, would be interesting because storing wood, it's very complicated because you have the wood that degrades, and you have a high concentration of humidity. Whenever you want to burn it, you can use it. And it's a challenge because it's going to petrify. You lose heat value of the wood if you leave it as it is in natura. And the pellets is also convenient because you increase the calorific value of the material, and they're also not only per kilogram but also per volume, because you make it more compact, which increases the viability of storage and also increases the efficiency if you burn in gasifiers or in incineration plants. It's also used because in Europe, in the US, there are a lot of people that use these wood pellets for heating in their houses, for heating up water, for taking showers and washing. This is also a good approach for decentralized energy supply for heating in countries. It could be used also in Brazil for process heating, for industrial heating, and have several benefits compared with wood chips, which is usually used in Brazil. So there is one power plant in the UK, which is Drax, which has 2 gigawatts of installed capacity. And I would like you guys to watch this video, and they're gonna show how Drax managed to turn itself into a biomass power plant. So Drax used to be a coal-fire power plant, but the UK and Europe has decided to abolish coal power plants. So they had to make a new design, and this is the solution that they found, and it's a very good solution. And Brazil would also have a huge potential for this technology. Please, can you please put this video on? Thank you. Did you guys finish the video? Right. So this is the top innovative solution for storage of pellets. Pellets are convenient because they're not like water that increases the pressure on the bottom. The pellets, storing these pellets is a huge challenge, of course, but with these domes, the structure, the weight distributes itself, allows it to store in very high, 30, 40 meters domes like this. And they're inflatable after the structure is strengthened in order to manage to cope with the weight. But it's very good approach for storage. For example, if you look at I don't have the picture here, but if you look at the cold storage sites that you need, it's huge, has a huge fire hazard. It produces a lot of particles around the coal power plants, which is not so great. So having such a solution for biomass also would release a lot of dust in the air. The humidity would increase. You wouldn't be able to use the biomass, the pellets, if it rains, for example, because of the amount of water in the pellets would increase, and then the efficiency of the boilers would substantially reduce. This is a very interesting solution. So the benefits is the small footprint because of the height. So you store at very high levels. The deep foundations options deal for port locations, superior product projections through climate control, pest preventions thanks to monolithic construction, monitoring systems to maintain interior conditions, low corrosion, because the alternative is usually steel silos, steel vessels, have substantial corrosion from the biomass, and resistance to extreme weather. So these are the benefits of these domes. And I was looking into compare how much these domes store. One of these domes, they store 90,000 tons of pellets, assuming calorific values of 20 megawatts per kilogram. You would have that one of these domes for around 200 gigawatts hour. 200 gigawatts hour is equivalent to 8 gigawatts day, 0.35 gigawatts month. So for example, one of these domes would supply the amount of energy equivalent to a biomass plant of 350 megawatts, which is a reasonable size. It's a large biomass plant. The one that we are looking, that we watched the video, is 2 gigawatts, but it used to be a coal power plant. They want to build it into a biomass power plant, fire power plant. They build all this infrastructure to import the wood from the US. And it's, for example, it's from Texas to Florida. They have several pellets production plants. It is a huge project. It's a lot of wood, and they bring all from the US and they make it viable. So I'm sure that Brazil can work it out and produce one of these biomass plantations, which won't require to bring from very distant, and is one alternative for Brazil. So compared with the storage capacity from SIM, from the Sistema Interligado Nacional, we would need around 835 domes in order to compare with the storage capacity that Brazil has with the reservoirs, hydropower reservoirs. Given that we only use 1/3 of the storage capacity in normal years or in crisis years, so around 100 gigawatts average 100 gigawatts month of storage per year, so we would only require 288 domes like this. These a lot of domes, but just to put into perspective, of course, we don't need all the energy storage in Brazil to be with pellets. But if we have, for example, 28 of these domes, it would store around 10% of the energy provided for electricity generation in Brazil. Sorry, I didn't take into account the efficiency of the plants. So these plants are usually 35% efficient. So you have to multiply this 288 domes by 0.35. And then, yeah, you have more domes. Yeah, a lot of domes. Yeah, so maybe it's not a great solution for seasonal storage, but because it's a lot of domes. Maybe it is, maybe not. You have to make the calculations and see. 122 domes you need to supply the Brazilian energy storage capacity. So the pellets production in Brazil has increased from 2014 to 2018. This is the amount of pellets production in tons. There is solutions for producing pellets from.
Julian?
Hello?
I have a question. In the case of England coal power plant, if you have a local coal, is it environmentally viable to bring pellets from another continent?
Yeah, usually when you have woods and you're carrying wood, it has to be, in order to make it viable, usually it has to be brought from 50 to 300 kilometers away, because the fuel that you spend carrying the biomass increases a lot the cost. So their solution, they have these pellet plants which are built close to port facilities, and they have these also storage sites in the port facilities, and they try to reduce as much as possible the land transportation. But it's still it's around 3,000 kilometers away, 4,000 kilometers away, Florida from England. Of course, you need a lot less fuel in order to transport by sea, maybe 20% of the fuel that you require by land, but it's still substantial amount of fuel. There is a video on this on the sustainability of this solution, which is very interesting. It's half an hour, so I wouldn't want you guys to watch it because it's a long time. It's tries to argue that it's a sustainable solution. I don't buy it really, but yeah, they have their arguments in this video. Very good video.
Okay.
You can watch it later. But it's debatable, of course, because I mean, if the ship is propelled with hydrogen, and the hydrogen is produced from green sources, so green hydrogen, renewable energy sources, then you wouldn't have any CO2 emissions involved. Maybe on the production of the components of the ship and stuff, and other indirect emissions, but then the sustainability factor would definitely increase, but it's still debatable to burn biomass from the US in the UK and argue its sustainability. So it's very debatable topic. It's very difficult to. Very good question. In Brazil, it will be much more sustainable if you produce the biomass in Brazil and you use it in Brazil. So it's an option that we could consider. Thanks for the question. Right, so pellets from sugarcane bagasse. Also, there is a possibility, and people are selling this and they're trying testing to see if it works. Wood bagasse, they have to dry the biomass first, then they shred the biomass, and then they pressurize at high temperatures, and then they produce these pellets. The energy consumption for this process is usually 10%, 15% of the energy within the biomass. So it's a relatively high energy consumption process, but once you have the pellets and you want to generate electricity, the efficiency from the energy solution that you have might increase from 25% to 40% because of the increase in calorific value and because of the higher heat volume ratio. So Brazil produces 0.07% of the pellets around the world. Now this is in million of tons per year, or maybe 0.1%. US produces 30%, 25%. Canada, Switzerland, Germany, mostly European countries, and US and Canada produce pellets. I said India. I'm sorry, India does not produce many pellets. The other one is the demand for pellets. So Europe is the country with the most demand, and the US produces most of the pellets to export to Europe. Europe is driving this pellets market. This is the capacity factor for pellet plants. So pellet plants in Russia are the highest, the ones that operate the most. So they're the whole year producing pellets, not the whole year, 70% of the time producing pellets. In Brazil, it's 63, probably because the infrastructure for pellet production is expensive, so they want to use it the most. And Brazil has a high interest rate, so whichever industry you have, you want to use as most as possible. But in average, varies from 40 to 30%. The capacity factor of these pellet plants. So pellet production in Brazil, mainly in Santa Catarina, Paraná, and Rio Grande do Sul, and some in São Paulo. I mean, São Paulo has more pellet production than Rio Grande do Sul. The solution that I think is a very good solution for Brazil for biomass production, you guys can go ahead and write a paper on it or do whatever, make a business out of it. And if you do write a paper, please invite me, because I'll be very happy to contribute to the paper, which is to build this biomass power plant, wood pellets production and storage close to the Iguaçu River, Paraná River, so in the Iguaçu Reservoir or in the Porto Primavera Reservoir, because, for example, all the biomass that you have planted around this area, you can transport into a ship, a barge, which would use the velocity of the river, which around this area is around 3 to 4 meters per second, so 15 kilometers per second, and you can essentially reduce the fuel costs for transporting the wood, And then once you reach the reservoir, the speed reduces because it spreads out the water. But you can still increase the amount of area that you can produce and extract the wood from the reservoir. You can use the reservoir as a transportation facility for the solution. And then when the barge is empty, so very light, and there's not much wood inside, you go up the river. So you don't need to fight the current of the river with a full barge. You go with the empty barge up, fill it up, and you go down with a full barge. And then I was thinking about El Dorado. El Dorado is the highest, biggest paper industry production in Brazil. And they had the same idea. So they have their biomass plants close to Paraná River on the end of the reservoir. So this is the Itaipu Reservoir, this is Porto Primavera Reservoir, and this is Ilha Solteira Reservoir. I'm not sure that that's the reason why they did this, but probably they put their paper industries close to these dams, the end of the reservoirs, in order to use the flow of the river and reduce fuel costs for production of paper and cellulose. So my proposal for a 2 gigawatt biomass plant in Brazil would be somewhere around the reservoir of Itaipu. Then you can bring the wood from. So this hydropower plant, which is Porto Primavera, has locks, so you can transport wood. And this one also, Ilha Solteira, has locks. You can bring the wood that's produced here all the way down using the flow of the river, and then go back. So then that reduces the cost of transportation. So I was looking at El Dorado power plant in Três Irmãos, the state of Goiás. They have a port here. Look, this is the size of the truck. Look at the size of the ship. So they have two ports for ships in order to transport the wood. A very interesting strategy that can also be used for. And I found out also that El Dorado has its own biomass power plant. It's a 50 megawatt power plant. It's called Onça Pintada. It was finished this year, and it uses eucalyptus. So if the cost of paper increases, they reduce the amount of wood that they burn to produce electricity. If the cost of paper reduces, they burn more to produce electricity. Maybe the cost of electricity is very high, which makes more sense to buy paper, import paper, or reduce exportation and use the wood for electricity generation. So biomass is very interesting to have several products. So if you have several products, and then if all of them are cheap, you burn, or if electricity generation is very expensive, you burn the biomass and you reduce the other products. Any questions about generation? This is incineration. No questions, so let's go to biomass gasification. So let's watch another video, because it's much better to watch a video to explain how gasification works. So gasification, you get biomass and you produce syngas, which is mainly carbon monoxide, 30 to 60% of carbon monoxide, which is CO. It's not CO2, it's CO, so it still has some calorific value, and 25 to 30% of hydrogen, which is great nowadays because everyone's talking about hydrogen. Wasn't great in the past, but now it's becoming very fashionable. Hydrogen. Shall we watch?
Hello, I'm Steve, an engineer with the Department of Energy, and I'm going to explain what way by breaking down coal into molecular building blocks that can be reassembled primarily with oxygen and water to make plastic, clothing, gasoline, diesel fuel, fertilizer, and electricity. So, how does gasification happen? Let's start with fire, also called combustion. Wood, like coal, is mostly made up of carbon, hydrogen, and compounds that do not burn, called ash. Air is mostly oxygen and nitrogen. During combustion, oxygen bonds with the carbon and hydrogen, creating a chemical reaction that gives off so much heat it produces fire. The soft ash left behind would have to be carefully landfilled to prevent leaching of contaminants into the ground. Gasification is similar to fire or combustion, but it occurs in a closed vessel. Less air is provided then for combustion, and water is added as steam. Oxygen chemically reacts with the carbon in the coal to become carbon monoxide. The hydrogen atoms in coal become hydrogen gas molecules. The water also provides oxygen to chemically react with carbon, leaving hydrogen behind. These chemical reactions give off heat, but less than if the coal were completely burned. The product of gasification is syngas, which is primarily carbon monoxide and hydrogen molecules. The sulfur in coal becomes hydrogen sulfide, which is separated from the syngas and is used to make sulfuric acid, which is then sold. Due to the high temperature inside the gasifier, slag is made instead of ash. Slag is like small rocks, and contaminants remain safely trapped inside, so slag can be used to make roads. Whereas gasification breaks coal down into small building blocks, other processes not covered here will reassemble these molecular building blocks, hydrogen and carbon monoxide, into all of these valuable products. To make clean energy from coal, we need hydrogen. To make more hydrogen, the water-gas shift reaction can be used to exchange each carbon monoxide molecule for a hydrogen molecule. When syngas is combined with steam and a catalyst, the water molecule gives off its oxygen atom to the carbon monoxide, turning carbon monoxide into carbon dioxide. Catalysts are used to increase the speed of chemical reactions. DOE's vision is to use hydrogen to generate electricity in a power plant with only water going up the stack. Coal can indeed be used to make clean electricity. But gasification is not limited to coal. Wood, natural gas, oil, and farm waste can all be burned to make heat. They can also be gasified to make clean electricity, clothing, fuel for cars, trucks, tanks and jets, and other products we use every day.
Right.
Clean coal gasification can be done today. DOE is developing technologies to make this vision affordable. To learn more about these technologies and gasification in general, enter Gasifipedia into your preferred search engine.
Professor, your mic is off.
Thanks, Anna. Sorry about this. Awesome. So now you guys know how gasifier works, and usually you should use for gasification biomass, which it has less than 20% of humidity by weight. So, for example, plastics, paper, cardboard boards. So these are urban municipal wastes, dry urban municipal wastes. For example, rice husks, leaves, branches. So all these you can, dry leaves. So wet leaves, they wouldn't gasify so well. It has to be very dry in order to reach 3,000, 4,000 degrees Celsius inside the gasifier in order to produce syngas. And syngas, as you heard, is carbon monoxide and hydrogen, which can be turned into only hydrogen and CO2. Hydrogen is a very small molecule, it's easy to separate from CO2. So then you can easily store the CO2 and have carbon capture storage, biomass carbon capture storage. biomass carbon capture storage is what everyone's talking about, and IASA is talking about. It's like crazy. They want to reduce the amount of CO2 in the atmosphere, and if they want to do it, gasification is the best alternative. So benefits of gasification: produce viably the generation capacities of lower than 0.5 megawatts, which allows a plant to operate with small amounts of biomass. So the main benefits nowadays that you can generate electricity with very small amounts of biomass. Incineration, on the other hand, you need a very large boiler, you need very large plants, which you need a lot of a large volume of biomass. So now the benefit is that it operates with small amounts of biomass. The other benefit, as I said, is produce hydrogen. Hydrogen is also going to be very important in the future. One particularly interesting project that you guys can also publish or work on it or develop a project on the subject is that gasifiers, they are small and light, so you can put these equipment into a container, and instead of transporting the biomass into the gasifier, you can have, for example, rice husk plant that instead of bringing the rice husk from different locations, you take the gasifier to the rice husk plant. You would need to have, for example, a substation in order to sell the electricity to the grid, or in order to use the electricity in your plant. So it would be interesting to have this infrastructure together with, for example, a solar power plant, because then the substation that you already have, you have the electric system required in order to connect your biomass gas fire, your gasification plant into the grid, because this is around 10%, 15% of the cost of the project. So the idea is that you put this in a container. For example, 1 month you go to one of the plants that stored some of the rice husk or any other waste material. You store it in a container, in a storage facility, and then you consume all the biomass, and then when it's finished, when you don't have enough, you just put the container back into a truck and then take it to another location. This is an interesting strategy in order to make viable this gasification with low amount of production facility. So a facility that has a very small amount of production, where you can just store your biomass and then burn whenever you have these gasifiers available around. A huge benefit of this type of solution, gasification, biogas, or any other solution that treats urban waste, is that you prevent the production of methane from the waste, because if you leave the waste in landfills, what happens that it biodegrades, and this biodegradation produces methane, and methane has a much higher capacity for increasing the temperature of the world. So it's a much stronger greenhouse gas than CO2. So it's 20 times more potent than CO2. And then instead of having the waste degrading, if you gasify it, if you produce biogas with it, if you incinerate, that's going to save you a lot of CO2 emissions and methane emissions, which you could, if you're clever enough, you can design a project that takes this into account, and then you get more credits, carbon credits out of your project. Instead of reducing just one CO2, you have the power for 20 times higher than the CO2 potential for greenhouse emissions. and then you make a project which is viable, and you get a lot of money from the carbon mechanism, CMDs. I forgot exactly what's the name, but there are a lot of people paying money for you to reduce CO2 emissions and methane emissions. So as the video showed, you can produce electricity, hydrogen, diesel. You could also produce ammonia, for example, if you have difficulties in transporting the hydrogen. And if you want to produce produce hydrogen and reduce the CO, carbon monoxide emissions, which are very dangerous, you have this water gas shift stage, which transforms carbon monoxide into hydrogen. If you want to only generate electricity, you can burn the carbon monoxide without turning into hydrogen, which is much cheaper and much more convenient. But if you want to produce only hydrogen, then it's worth to turning the carbon monoxide into hydrogen. And as I mentioned, this is a very good approach for carbon capture storage, because you come up with hydrogen and carbon monoxide, which have significantly different sizes, and they are easy to separate. And then if you separate the hydrogen from carbon monoxide, you can store it in geological formations under the power plants or any other type of long-term carbon storage. So now looking at wet biomass, we are 1 hour on. Any questions about dry biomass?
Hi, Professor, can you hear me?
Yeah.
Yeah, I've been reading during the vacation, I think, about the town gas. It's very similar to this syngas, I believe, that they had in England, for example. It's only from coal, I believe. And then I remember right now, because of the CO, they decided to prohibit in England, because people used to commit suicide, the end customer. For example, if you have in your apartment this gas, people used to commit suicide because the CO. So I believe the gas will never be available for people around, just for industries and something like that, I believe.
Yeah, thanks, Federico, for sharing your experience. Yes, in Rio de Janeiro, also we had the gasômetro, which used to gasify coal in order to produce syngas, and people in Brazil used to use syngas. Also in Rio, used to use syngas for cooking fuel, for boilers, and it's not only suicide. For example, if you forget your gas oven on at night because you forgot to turn it off, and it's not firing, so a kid goes and turn it on, he also kills everyone in the apartment. So it's very, very dangerous. And in Europe, actually, even natural gas, they are banning natural gas because the houses in Europe, they are completely sealed. They have these windows, double glazed windows that they close. And if you forget the natural gas on, or you forget the oven on, turn with fire, it consumes all the oxygen in the building. And this actually helped with how it happens with me and Paula. One day we were living in Vienna. Thank God our windows were not extremely sealed, and we forgot the oven on. And then in the morning, she tried to light a candle. She wanted to pray, and the candle didn't fire. The fire in the candle was very small because all the oxygen in the apartment was consumed by the flame. I woke up with a huge headache. I could have died also. So these, particularly in houses that you have double glazed windows, very efficient, high efficiency heating installation buildings, it's very, very dangerous. And nowadays in Europe, if you have a house which has this double glazed windows and with no entrance of air from outside, you're not allowed to have gas ovens. It has to be electric ovens. So everything, the boilers are still gas, but the boilers have to be checked every year. So yes, you're completely right. Syngas is the most dangerous one because of the carbon monoxide. But all the gases, I don't know hydrogen. So far, I don't have experience, but each of these. Any other questions? Or let's go ahead. Biomass. As a fuel, carbon dioxide in your tank, this carbon dioxide is not going to burn. It's just going to occupy volume in your machine, motor. When it burns, it's going to produce less heat. And when it burns, it has to heat up the carbon dioxide. So the calorific value of biomethane is much higher than the calorific value of biogas. So if you put biogas in your tank, it's not going to perform as well. It's going to have much less efficiency. It's not going to reach the same power, your motor, and you might even break because it's not built for this type of fuel. Right?
Thank you.
You're welcome. And you have this other section of the biodigester, which is a storage part. So during the day, for example, when it's warmer, you have solar radiation increases the temperature of biodigester, you produce more biogas. So then this, the gas inside also increases in temperature, which increases the volume. So this membrane varies, increases, reduces. So this top part is just air. It's outside air, which is blown with a pump, air pump. An air pump makes sure that the pressure in here is slightly, maybe 0.2 bar higher than the pressure outside. And the pressure in here increases because biogas is produced and this inner membrane rises. So this is how a biodigester works. This is another example of biodigester. This one has a steering capacity, so you use energy in order to steer the organic compound, which is flowing around here, that increases the production of biogas. You have different other steering mechanisms. This is a valve, uma hélice, which turns also the material in here in order to increase the. So in the same case, this is the lowest level. If the membrane here lowers down and reaches here, so the biodigester is empty. The storage capacity is empty. When it rises, because it's filling up. So in the biodigester, it's important to have storage because most of the cases you want to produce a constant amount of biogas. And sometimes you produce more, sometimes you produce less, depending on the temperature, depending on the concentration of the material in your bioreactor. And this variation, for example, if the biogas production starts to lower, then you can increase the temperature, or you can put material which has more calorific value, which produce more biomass, and then you can control the amount of biogas production. So this is an example of how the biodigester works. This is another biodigester. Another benefit of this type of plant, particularly in Europe, is that the air in this membrane also contributes to reduce the heat losses within it's like an insulator, because air inside here, it's sealed inside between the two membranes, the outside membrane, the inner membrane, reduces the energy losses for the biogas reactor. I don't know how to read in German, but I can understand some of the concepts here. Biogas storage. So after you produce in your bioreactor, this you can have a facility that only stores the biogas. So it's not the bioreactor. You produce the biogas, you remove the gas hydrico, then you store the biogas or the biomethane in one of these domes. It has a similar mechanism. So basically, you have a pump, air pump, that makes sure that this pressure of this membrane is always 0.2 bar higher than the atmosphere, so it's standing all there. And this inner membrane, so this is the outside membrane, the inner membrane will vary according to the amount of biogas inside. And the pressure is pretty much the same as atmospheric pressure, maybe 0.1, 0.2 bar higher than atmospheric pressure. So these, in order to store a lot of biogas, these domes has to be very large, huge. So when I talk about balloons transporting hydrogen, and you see it starts to make sense because it's pretty much the same concept, but you leave the balloon to fly and to collect it in another location. So this is another representation. You have the air here, the pressure, pressurizing this. When you increase the amount of methane, you have to remove the air from this section between the outside membrane from the inside membrane. The total volume is constant. So if you put gas in, you have to take air out. Biogas in this inner membrane, you have to take air out from between both. It's very straightforward. But very, very interesting though. So this is a material. This is a kind of a balloon material, very resistant and cheap approach for biogas storage. For example, if you have one plant that produces electricity constantly, so 24 hours a day, your generator, you would need a 600 kilowatts generator. You might need a little bit of storage just to make sure that you always have biogas to produce as base load. But for example, if you want to generate during peak hours, during hours where the cost of electricity is higher, you will need to have more generation capacities because you will burn more gas in a shorter amount of time. And you need also to add storage. The amount of gas that you have to store increases. This type of solution is good for daily or weekly energy storage, biogas for production of electricity, or for example, delivery of biomethane if you have a station that produces biomethane. And yeah, so there are different options for storing biogas. You can store in this double membrane storage type, which I just talked to you about. You can store in tanks, so gas storage tanks, medium pressure or higher pressure tanks. The main challenge is that you need to pressurize the gas. You spend energy and you need to buy the pumps in order to pressurize the gas, and then after pressurizing the gas, you store in these medium pressure tanks. But for example, so I'm going to talk about medium and high pressure storage, gas storage tanks after. But for example, if you in the thermoelectric power plants of Cuiabá from JBS, they have a power plant that receives gas from Bolivia at 60 bar, 80 bar. So there is no point in having these type of storage tanks because these storage tanks is at 1 bar. If you already have gas at 80 bar, you might as well just build a storage tank, a high pressure storage tank which will be substantially cheaper than this type of storage. So the pressure is much higher. You need much less volume, much less material to store the same amount of gas. But the advantage of these double membrane is that you don't need to increase the pressure of the gas. You can store it with low pressure, with ambient pressure. So comparing the price for this energy storage solution, as I have been doing in all the lectures, you have two options. So a small storage facility with 50 meters cubic, or the highest one, which is available from Alibaba, which is 20,000 meters cubic. And the height goes up to 25 meters high, very high. These are the material that the membranes are made, the membranes outside and inside membranes. So the heat content of biogas is around 21 megajoules per meter cubic, which is equivalent to 5.8 kilowatts per hour per meter cubic. And then if you multiply by the volume, you have the investment cost of $2.9 per kilowatt hour storage. Compared with batteries is $200 per kilowatt hour. So it's around 70 times cheaper to store biogas than store electricity in batteries. Because you need to have biogas, you need to have the farm, you need to have a bioreactor close by. So it doesn't apply to every case, but it's cheap. So it's very cheap to store biogas. So assuming a 50% capacity factor, so for example, you fill up during the day and you use it, you fill up during the night and you use it during the day. So 50% of the time you fill it up during the day and you use it during the night. So if you use the full capacity, would be 100%, but in this case you're only using 50% of the capacity. You have the discount factor, and then you multiply the investment costs, and you put into this equation, and you have the cost of storage, which is very low, and you multiply by 5.5, which is in reals. You have 0.36 reals per megawatt hour. This is if you're talking about this very large dome and you have a lot of biogas to store. If you have not so much biogas to store, then the cost increases to 7.3 reals per megawatt hour. So compare this small tank with batteries. Batteries in reals, so the levelized cost of battery in reals is around 130 reals per megawatt hour, as we talked in the past. So 130 per 7 is 20 times cheaper. That's 20 times cheaper than storing energy in the battery. This doesn't take into account the fact that you need to buy another generator. So you need to buy, instead of one generator to work as base load, you need 2 generators. So that you generate a lot of electricity during peak time. So this cost is only for storage, it's not taken into account. Of course, this system, you have to add several other costs, which will increase the overall cost. But here, as we're giving a lecture on energy storage, we just look at the storage cost. So as I mentioned, you can also store gas in high pressure tanks. So these pressure tanks can go up to 250 bar. Given that I gave you the example for the power plant in Cuiabá, that's 80 bar. So for example, you have one of these tanks which can store 150 bars, but you only use 80 bars, so you're not using all the potential for these storage tanks. But anyway, the cost is very cheap because we in a small, you need 80 times smaller volume to store the same amount of gas because it's pressurized. And then the costs is much lower than the cost of biogas storage, 0.3. The high pressure is 0.02. So it's more than 10 times cheaper to store high pressure gas than store low pressure biogas. So this is why it makes sense the US has several of these high pressure natural gas tanks for seasonal storage. It's for seasonal storage, you're not storing a gas for a day. You're storing gas for 365 days. It has to be 365 times cheaper than storing electricity for one day, which is. So you have a lot of these natural gas storage tanks around China. Even in ports in Brazil, you have some of these when you have these regasification plants, you have storage tanks, natural gas storage tanks. And they are cheap, very cheap. Any questions about wet biomass? We have half an hour. Okay, so we're going to talk about ethanol energy storage opportunity. Ethanol is mainly made from sugarcane in Brazil. You can store sugarcane bagasse in pellets. As I mentioned, you can produce pellets from sugarcane and store in these domes for example, biomass generation, as I already talked to you. For the sugarcane is used to produce sugar or ethanol in refineries, sugar refineries. The sugar you can store in tanks for 2 or 3 years, depending on the quality of the storage tanks. And the ethanol you can also store in tanks. So if you have demand, depending on the demand, you always will be able to make the highest amount of returns in your refinery if you can store sugar and ethanol. Because the sugar price increases, you sell more sugar, ethanol price increases, you sell more ethanol, which is very convenient for the industry. The production of ethanol nowadays, the most advanced one, you have the sugarcane, and you use it, you squeeze the saccharose, and then you put into fermenters, and you ferment with it's not anaerobic digestion, it's aerobic digestion. I'm not 100% sure. Is that anaerobic digestion or aerobic? Does anyone know? I don't want to confuse. I'm not 100% sure. You ferment this
Anaerobic. If you have
aerobic.
fermentation, is anaerobic without oxygen.
Thank you so much. So anaerobic fermentation without oxygen, with just a little bit of oxygen, and then you produce ethanol. You have to distill the ethanol in order to separate the ethanol that you produce from the rest of the byproducts. And another form of ethanol production is using the bagasse. So you use the bagasse, we can use it for generating electricity in cogeneration plants, or you can use the cellulose, the bagasse, in order to produce more ethanol with second generation ethanol. You have this stage of hydrolysis which you manage to break the cellulose and produce smaller parts of which you degrade the cellulose, and eventually it becomes saccharose, sugar. And you also can produce ethanol with the sugar, the bagasse of the cana. This is the second generation product. And you also can produce from corn. It's very funny that people say, oh, corn is not so great alternative for producing ethanol, but I'm going to talk to you maybe today, maybe tomorrow. I don't know if we have time, but the US is producing corn ethanol in Brazil with money from Hanover Beer. So we are also producing sugarcane from corn a little bit in Brazil. And corn is the main resource used for ethanol production in the US. So looking into biofuels in Brazil, you have that, fuels in Brazil, you have a lot of diesel is the main fuel used, then gasoline, ethanol, biodiesel, and a little bit of GNV. And these values, they vary substantially, for example, with crisis, with oil prices increasing, oil prices reducing, particularly with ethanol production, and you also have the biodiesel increasing. Now biodiesel is something around 5 to 10% of the production of diesel in the country, and it's increasing exponentially. It's very interesting. We're going to talk about biodiesel. This is another graph, but with percentage, so varying by percentage, not an absolute value. You have biodiesel here. It is more recent also, so this is from the Balanço Energético Nacional de 2022-2020. And it's already 10% of the production of diesel and consumption of diesel in the country. Biodiesel, you have alcohol. Alcohol increased the percentage in the last years because of the increase of oil prices after 2018, which reduced. 2018, the oil prices went really low. Then 2015 went low again and increased. Now, of course, they don't show COVID here. It will probably drop significantly because of COVID. But it's very interesting, this graph. They have a lot of information, but let's keep going. So one huge benefit of ethanol production from sugarcane is that you can also produce sugar. If the cost of sugar increases, you reduce production of ethanol, produce more sugar. If the cost of oil costs increase, you reduce the production of sugar. You can import sugar from other countries and use it for production of ethanol and reduce the cost of transportation in Brazil. And this is more or less in Brazil how the cost of ethanol and sugar varies. Sometimes they follow the same pattern. Sometimes the sugar prices increases. So, for example, in 2019, the sugar price increased compared with ethanol. Here, it doesn't have COVID prices, but in COVID, the sugar prices rose significantly and ethanol prices reduced. So nowadays, these refineries are producing much more sugar than ethanol. Regarding biodiesel, mainly in Brazil is mainly produced with soy plantations. Soy plantations and soybeans can be stored seasonally and pluriannually in storage tanks, which is very convenient for these fluctuations of prices in fuel, having soy as a source of biofuels due to this storage potential. Then the soybeans, they go into diesel generation production, which I'm going to talk in more detail. And then the diesel can be stored in tanks, like similarly to ethanol, similar to natural gas tanks. And it's relatively cheap, and you can store it seasonally and pluri-annual storage. And diesel is mainly used for transportation. It's also used for electricity generation during peak hours and diesel generators. Right, so the soybean goes to oil industry plants. So first you need to extract the oil from the seeds, which you have several processes. You can do it thermally, you can do it chemically, you can do it mechanically, different process in order to extract the oils. Once the oil is extracted and purified, it goes into a diesel production factory, which I'm going to explain further in the next slide, the main compositions. Then you have the main processes, then you produce diesel and you distribute mainly for transport sector, but also for peak generation. So the main reaction that happens in diesel refinery, it has the vegetable oil has glycerin, so it's a trans-esterification reaction. So the idea is to turn this lipidus these gorduras into lines of hydrocarbonate lines. So this is ácido, hidróxido hidróxido de metano, hidróxido de etano, pentano. Normalmente esses R's daqui tem 20, 15, um radical de 20, 15 carbonos, né? Depende do material utilizado para a produção de biodiesel, você vai ter radicais diferentes. So the process, you combine, you react these lipids with alcohol, and then you produce glycerin and these radicals, these acid radicals, which is the biodiesel. So the advantage of biodiesel is that these radicals, these molecules, they are biodegradable. They react. They store water within these hydroxylas. They store water more than normal diesel, because normal diesel doesn't have these hydroxylas. And these hydroxylas, they make it more challenging for storage. For example, if you leave a biodiesel tank for 3 months, then it's going to create algae inside and microorganisms, and it's going to increase the water content. So the storage of biofuel is more complex than biodiesel, is more complex than diesel because of these hydroxyls. So biodiesel is mostly used in the agro sector, mainly because it's the agro sector is producing it, and then it uses the biodiesel that it produces in its own production. Lower the cost, it doesn't need to pay gas, and it's close to the production sites and have other benefits. The owner of the plantation probably has a stake on the biomass refinery. So I had a look into the biodiesel production in Brazil. You have a slightly seasonal production, mainly because of the harvest of soybeans, which happens around this period in Brazil. The main producer of biodiesel in Brazil is the state of Rio Grande do Sul, with 27%, then Mato Grosso, Goiás, Paraná, Bahia, Mato Grosso do Sul, São Paulo. So, I mean, we're in the Federal University of Rio Grande do Sul, so it's a great business there. 80% of biodiesel is produced with soybeans. 15% is with cow manure and blood, and gordura da vaca. Mainly by JBS in Mato Grosso and Lins in São Paulo. They have 2 huge power plants, biodiesel power plants, and they're building one in Santa Catarina. I forgot the name of the city, but it's the biggest, and it's going to be bigger than the 2 other combined. Mafrig also produces biodiesel, so other companies also produce biodiesel from animal waste, organic waste. So soybeans mostly used as feeds, to feed pigs and chickens and cows. 20% is to produce oil, and it's mainly for food production, but it's also used for biodiesel. So 25% of the oil produced from soybeans is for biodiesel, and also other industrial materials that oil is used. Brazil is the one that's producing the most soybeans in the world. This passed the US in 2018, and is expected to considerably increase production, and much more than the US. In Brazil, soy production mostly goes to China to feed its meat consumption. So biodiesel is a great alternative for this market because we have one market, which is to feed animals, and having biodiesel as another alternative for uh, to diversify the business of soy plantation. It's a great opportunity for Brazil. And another interesting aspect is that the exportation of soy to China varies with exportation from the US because we're in different hemispheres, and does the harvest happens in the different seasons. And also biodiesel requires storage, and the storage would also improve this dynamic of seasonal importation exportation, mainly because Brazil will surpass the US, so they'll have to store more because this synchrony of exportation won't happen anymore because Brazil will produce much more than the US, and they'll have to increase storage in order to maintain a continuous flow of exportation of soy to China. The benefits of diesel: renewable fuel, has less sulfur than normal diesel, create jobs in the countryside, is biodegradable, so this could be an advantage or disadvantage. It's mainly a disadvantage in my view. It has high lubrication characteristics, so it's good for the motor, keep it lubrified. The problem is that it's, as I mentioned, you have organic degradation, you have microorganisms, crystals formed within the biodiesel. It absorbs water, which reduces the calorific value, which is the problem for storage, mainly for storage. Another interesting aspect of biodiesel is that some sources of biodiesel have different calorific values. So in order to have the perfect mixture, you might have to mix biodiesel from soybeans with biodiesel from cow manure, from frigorificus. You have to have a mixture. Maybe you have to add some other chemicals in order to reach the right calorific value, and also the octanaging. Octanaging is very important for diesel fuels, mainly because it doesn't have a spark. So diesel engines don't need spark, so they don't have spark, and they ignite with increasing pressure. So the octanaging is exactly what's the pressure and the heat and the that you require in order for burning to happen in the engines. And also a challenge for biodiesels to get the right octanaging, which can be reached with adding different components. It might not even be biodiesel, it could be other components, organic components. Right, so now talk about Renova Bio. Any questions about biodiesel? Ethanol? Okay, so Renova Bio. Renova Bio is a new policy in order to create a market for biofuels with the intent of increasing, subsidizing, so it's creating more money to enhance this market for biofuels with the intention of creating jobs, reduce the CO2 emissions from fuels, fossil fuels, and because Brazil has a huge potential for biofuels and biomass, and it's a program in order to increase the viability of these fuels. But the main argument is to reduce CO2 emissions. So how it works? So the biorefinery, so a company that produces biofuels, it produces biofuels, and when it sells the biofuels that it produces, it gets a certificate. So it's the CBio. CBio is a certificate for biofuels. And this certificate, one certificate is equivalent to the reduction of 1 ton of CO2 to the atmosphere. And the number of, the amount of biofuels that has to be consumed in the market generally increases every year. And then the people that is selling the fuels, so for example, uma estação de petrol station, it needs to buy these CBIOs if they are not selling biofuels. So for example, if they're not selling so much ethanol, if they are not selling biodiesel in their postos de gasolina, they need to buy these CBIOs in order to comply with this policy. Right, so the producer produces ethanol, for example, and when it sells the ethanol, it can get the receipt for selling the ethanol for the distributor, and then this receipt will go into a calculator and estimate how much of that ethanol that was sold is equivalent to the reduction of CO2 emissions. And 1 CBIO is equal to the reduction of 1 ton of CO2 emissions. So the most efficient the production of ethanol is, the more certificates it will be able to make with the ethanol it's selling. There is a market which is organized by B3, where you can buy and sell these certificates, which is a result of RenovaBio. So we created a carbon market. So it's the first carbon market in Brazil. So there are several carbon markets in the world. In Europe, you have this clean mechanism, development mechanism, which is one carbon market, which people that emit a lot of CO2 can buy emissions from other companies, and it's a carbon market. So this is the first carbon market in Brazil, only in Brazil, it's just for Brazil, which is very interesting. And it started in, so the law passed in 2019 during Temer government, and it was implemented in July of 2020. So 6 months ago, the price was zero. And then the price increased rapidly because a lot of the production of biofuel production companies, they have a certification that they can produce, because you have to have a certification from ANP in order to be able to get these CBIOs, and then you can sell in the market. For example, if you have a ethanol production plant that produces 66 grams of CO2 per megajoules of fuel, and compared with the gasoline fuel, the reduction is only 20 grams per CO2 emitted, then for every megajoules of ethanol that you produce, you only get 26 grams per CO2. And then when you multiply and you achieve 1 ton of CO2 equivalent, you get 1 CBIO, which you can sell now for 50 reals, for example. So if you have a higher efficiency, a lower CO2 emission process, then you need to sell less ethanol to get 1 CBIO. So it depends on the efficiency of your plant. For example, if your plant is very efficient, you only need to, so with selling 685 liters of ethanol, you have 1 CBU. If your production plant, if the process for producing ethanol is not efficient, then you need 907 liters to produce 1 CBU. And I made an estimate of the cost of ethanol, and assuming that CBU cost is 60 reals, another BU would give 2.5% in a revenue. So it will increase the revenue of the ethanol production in 2.5%. So it's a reasonable amount of money, and so increases the viability of biofuels. I have 10 minutes. I'm just skipping some slides. So Hanover BU had a bad turnover now because the government decided to reduce the metas, the targets. It reduced in half the targets they had to be met in 2020, mainly because also the target was not going to be met due to several reasons. One is because COVID lowered the price of gasoline, so more people are using gasoline. Also, COVID increased substantially the cost of sugar. So the refineries are producing sugar. We had a bad production of bagasse because it was dry in the locations where they plant bagasse, sugarcane, sorry. And there were not all the plants that produce biofuels applied for a certificate, because in Brazil a policy only works when a lot of people make money, and it's a substantial investment in order to be certified to get these CBUs, and only 40 to 50% of the biofuel production industries facilities have applied for CBU. The other ones, they have not applied yet, so the number of CBUs did not reach the expected. And then they reduced the meta. So they're reducing the meta, the target. What happens is that it substantially reduced the cost for CBUs. Let me show the cost of CBU. So the cost of the CBU started at 0 in April of 2020 when it started, and then you increase it exponentially and reached 60 reals per CBU. And in December, when the governments mentioned that they would put this cap and they would reduce the meta, in December it lowered to 45 reals per CBU. So it's a market. It has a bolsa, which is managed by B3, and it's working. Great project. Congratulations to Brazil. I was very impressed. I didn't know anything about Hanover Bio 2-3 days ago, so I was very impressed. So how to calculate how much CBUs you get by selling your biofuels. So compared with gasoline, your ethanol production, because ethanol replaces gasoline, you have ethanol refinery of first generation. You have something around, you emit 46 grams per megawatt, and then the amount of credits that you get is a difference between how much you emit with the ethanol that you have minus, so how much you would emit minus how much you actually emit. And then so if you have ethanol with cogeneration, so it also produces electricity, it reduces. If you have biogas, if your plant also produces biogas in your plant, it further reduces the amount of CO2 emitted to the atmosphere. And if you have second generation, you have even more subsidy, so which even further reduces the amount of emissions, and then you get more certifications. And if you have carbon capture storage, you can have a minus CO2 emissions, which you can then increase the amount of CBUs that you have, depending on the price of CBU in the market. It makes sense. If it's not so high the price, it doesn't make sense to do biomass carbon capture storage. Yeah, so the market for CBUs is expected. This is a forecast. So mostly would be produced with ethanol, hidratado, hydrated ethanol, so ethanol with water, ethanol without water, biodiesel, and then biogas will increase slowly because we don't have so much. We have very limited biogas production. And for our lecture, I found that's very relevant for our lecture. We have that the certificate, you can only apply for the certificate 60 days after you're selling the ethanol, the biodiesel. And after 60 days, if you don't apply for the CBUs, you don't get it. It's expired, so you can't get it anymore. So for example, you can increase your storage capacity and wait for the market to increase, to lower, depending, for example, in a decision in Congress, you're waiting for the decision for the price to go up and down. So for these type of strategies, in order to make more money from your fuel, it might pay off to build more extra storage capacity in order to also make money with these CBUs production. This is just an example of another carbon market in California. There are several different carbon markets that have different mechanisms, and this is the first carbon market in Brazil, Renova Bio. Any questions? You guys know about Renova Bio? Any feedbacks? I guess we have 2 minutes for the end of the lecture. Right, if you have no questions, we can also have questions on the assignment, right? In 2 weeks, you guys have to submit the proposal, research proposal. Any questions on the research proposal? No. Okay, no questions. Thank you so much then. Have a